Good afternoon, friends. We have studied the digital communication subject in that fifth unit, that is information theoretic approach to communication system. And that our today's topic is channel model and channel capacity. In that, we have to study discrete memberless channel. This topic is under the source coding theorem. There are two types of channel: discrete memberless channel and binary symmetric channel. We have to study that both one by one. Here is the block diagram for the discrete memberless channel. In first block is input data, after that channel encoder, after that waveform modulator, after that waveform channel. Next block is waveform demodulator, after that detector, after detector channel decoder is there, and we get the output data. Composite discrete input discrete output channel is there. Okay, definition is a discrete memberless channel is a statistical model with an input x and output y. The output y is assumed to be the noisy version of x. Clear? Here both x and y are random variable discrete channels. A channel is said to be discrete when the message x and y have finite size. Memoryless channel when the current output symbol depend only on current input symbol and not to the previous one. The channel is called as memoryless. Hence, a discrete memoryless source has both properties. First is alphabet x and y are of finite size, and second one is the current output value of y depends only on current input value of x. Therefore, a discrete memoryless channel can be described as x is equals to x0, x1, x2 up to xn minus 1. Okay, and y output is equals to y0, y1, y2, y1 minus n. Okay, clear? Here in block diagram, the encoding process is a process that takes a k information byte at a time and map each k bit sequence into a unique n bit sequence. Such an n bit sequence is called code word. Second is the code rate is defined as kilometer per n, k by n. K means the information bit at a time and n is the unique n bit sequence. Clear? If the transmitted symbols are m array, for example m levels, and at the receiver the output of the detector which follow the demodulator has an estimate of the transmitted data symbol with AM levels the same as that of the transmitted symbols, then we say that the decoder has made a hard decision. Q being greater than M, then we say the decoder has made a soft decision. Okay, channel models. Here is the extension of discrete memoryless source. Let M be the extended source of symbol where M is equals to distinct symbol. In case of discrete memoryless channel, all the symbols are statistically independent. Hence, probability of the source symbol of an extended source is equals to the probability of product of n source symbol present in each data block. Example is there, let n is equals to 2, m is equals to 2. Clear? Then m of n is equals to 2 of m is equals to 4. 2 into 2, 4 distinct blocks of data present. Source symbol produce are 0, 0, 0, 1, 1, 0 and 1, 1. Their probabilities are P00 is equals to P0 into P0. P01 means P of 0 into P of 1. P10 means P of 1 into P of 0. And next is P11 means P of 1 into P of 1, because PAB is equals to PA dot PB. Therefore, entropy of extended source is given as h of xn is equals to n of xn. H of n is equals to n into h. As per properties of probability, we have 0 is greater than or equal to p y of k upon x of j, less than or great equals to 1 for all j and k. Now if j is not equals to k, this means size of input alphabet x and output alphabet y is not same. Then the transaction probabilities can be expressed as follows: p y0 x0, y1 x0, yk minus 1 xz. Clear? See in matrix. This matrix is known as channel matrix. In this channel matrix, row fixed channel input is there, in column fixed channel output is there. Fundamental properties of channel matrix are statement: the sum of elements along any row of the channel matrix is equals to 1. Therefore, summation of k of 0 to 1 p of yk upon xj is equals to 1 for all j. Second is joint probability distribution of x and y. It gives as p of xj yk is equals to p is equals to xj, x is equals to xj, y is equals to yj. P of y is equals to yk upon xj. Clear? Marginal probability distribution of y, it is gives as p of yk is equals to p of y is equals to yk is there. P of yk is equals to summation of j is equals to 0 to 1. P of y is equals to yk upon x is equals to xj. P x is equals to xj is equals to summation of j is equals to 0 to 1. P of yk upon xj. Xk means what? It's get into, as we studied previously, where pxj for j is 0, 1, 2, j minus 1. Now next is binary symmetric channel BSC. If A, the channel is an additive noise channel, and B, the modular and demodulator detector are included as part of the channel. Furthermore, if the modular employs binary waveforms and the detectors makes hard decision, then the channel has a discrete time binary input sequence and a discrete time binary output sequence is there. Okay, circuit diagram of BSC. Note that if the further noise and other interference cause statistically independent error in the transmitted binary sequence with average probability P, the channel is called BSC. Channel noise and other interference cause statistically independent error in the transmitted binary sequence with the average probability P. The channel is called a BSC. Besides, since each output bit from the channel depends only upon the corresponding input bit, the channel is also memoryless. Okay, discrete memoryless channel is there, no? Channel is the same as above but with QR symbol. at the output of the channel encoder and Q array symbol at the output of the detector, where Q of 3Q if the channel and the letter are memberless, then it is can be described by a set of Q of Q probabilities. X of xj, okay, plus is called discrete channels of x0, x1, xq minus 1. Block diagram of discrete memberless channel is there. Here, if the input to a DMC is a sequence of n symbols U1, U2 up to Un selected from the alphabet X and the corresponding output is sequence V1, V2, Vn of symbol from the alphabet Y, the joint conditional probability is P y1 is equal to v1, y2 is equal to v2. Clear? Up to ym is equals to ym. Discrete input continuous output channel. Suppose the output of the channel encoder has Q array symbol as above. The output of the decoder is unquantized. The conditional probability density function P y of. After that, waveform channel is there. Here is the block diagram of waveform channel. Input data, channel encoder, waveform modulator, waveform channel, waveform demodulator is there, detector is there, channel decoder is there. Look at the diagram. Okay, waveform. Here is with channel, waveform channel. In such a channel has bandwidth W with ideal frequency response of is equals to 1, and if the bandwidth limited input signal to the channel is x of t. Here is binary symmetric channel. Okay, it is a special case of discrete memberless channel with J is equals to K is equals to 2. Let the channel has two inputs, x0 is equals to 0, x1 is equals to 1, and two output, y0 is equals to 0 and y1 is equals to 1. The channel is called symmetric because the P y1 is equals to 1 when x is equals to 0 cent, and py is equals to 0 when x1 is equals to 1 cent. This conditional probability. Let P denotes the conditional probability. Transition probability diagram is shown in figure. It is in PDF also, right? Yes. Then information rate. If the source of the message generates r number of message per second, then the information rate is given as r. Information rate formula is there. R is equals to r into h. Small r is number of messages per second and h is source entropy is there. Clear? The unit of r is bits per second.